What are new and smart materials? The name doesn't mean that they are intelligent, it refers to the development of new materials with different and useful properties that a designer can use to create better products. Let's start with smart materials, which are materials that change their properties when their environment changes. There are three main types: thermochromic materials, quantum tunneling composites, and shape memory alloys. Thermochromic materials change color when exposed to heat, but they go back to their original color when they cool down. These materials were very popular in the 1990s in the form of hypercolored t-shirts, which highlighted the parts of your body that were sweaty by changing color. The color change is from the thermochromic inks, which change color as the product gets warmer. These inks are cheaper and more reliable than electronic heat warnings. They are also used in warning patches that tell you if something is too hot, for example feeding spoons for babies. Thermochromic dyes can be impregnated into clothing such as baby grows so that you can see when a baby has a temperature.
A quantum tunneling composite has nothing to do with sci-fi films. It's a polymer that is an electrical insulator, and when it is squashed, it becomes a conductor. And the more squashed it is, the better a conductor it is. How weird. This material can be inserted into textiles to control integrated electronics. Electronic devices can be included in a product design, especially in textiles, where MP3 players are incorporated into jackets and bags. These devices are often operated by a quantum tunneling composite, which is washable and can be permanently attached to the product. Integrated electronics can also be used in clothing to monitor heart rates and blood pressure. Nitinol is a type of shape memory alloy that can be easily shaped when cool. It returns to a remembered shape when heated above a certain material, which is ideal for spectacles. If your nitinol glasses are accidentally bent, you put them in a glass of hot water and they return to their original shape. Very helpful if you've sat on them.
Nanomaterials are made from nanoparticles, which are so tiny that you can fit thousands of them into the width of a human hair. They have useful properties. They are used to make self-cleaning glass for windows. The glass has a coating of nanoparticles that causes dirt to break down and can be easily washed off by rain. Self-cleaning fabrics are coated with particles that resist and break down dirt and stains. Antibacterial fabrics have silver attached to kill the bacteria, for example for use in face masks in hospitals and odor-free socks. When nanoparticles are incorporated into fabric, the particles are so small that they don't change the feel of the fabric, unlike other conventional fabric finishes. Could nanomaterials be used in plastics? Cornstarch polymers are often used to produce clear and flexible plastics suitable for sandwich packaging and disposable drink cups. Cornstarch polymers are made from maize and are renewable materials, so when you finish with them, you can put them on a compost heap to rot away. They are more sustainable than normal plastics, and this saves our oil reserves and creates less waste than goes to landfill.
The last material we are going to look at is precious metal clay, which is a new material that contains particles of metal, usually silver, in a binding material that is used to make jewelry. Clay as a material is really easy to work with, and with the precious metal you can still roll it out and shape it like modelling clay. When the clay is fired, the binder burns away and the metal fuses together to make a solid metal object. Once the jewelry has cooled, you can solder and polish it as you would normal silver jewelry.